So this says a curve C has the equation y equals px cubed minus mx, where p and m are positive integers. Find the range of values of x in terms of p and m for which the gradient of c is negative. So we're going to start off, because to find the gradient, we're going to do dy by dx. And this will tell us that 3px squared minus m is the gradient. So we know that this is negative when 3px squared minus m is less than 0. That's what you have to do. So now we just have to rearrange this to find out what x is at that stage. So let's add m onto both sides. Remember that we can't divide through by minus 1 or times by minus 1, otherwise it just won't work. So adding m onto both sides is fine. Dividing through by something positive, which is 3p, is also fine. And then square rooting. So that means that x squared is less than m over 3p square rooted, but that's plus and minus. So therefore, x is going to be less than the positive m over 3p, and it can be greater than the negative m over 3p. And that is how you do that. Right. Here are the first 5 terms of an arithmetic sequence. Work out the sum of the terms from the 50th term to the 100th term inclusive. So what you need to do is work out sum of arithmetic fractions, sum of an arithmetic sequence, which is this one. Hang on. So sum of an arithmetic sequence equals n over 2, 2a plus n minus 1d. And what was I going to say to that? Yeah, you got that on the front of the paper. So let's work out what the things are. So the difference between each is 7. So that means d equals 7. The a is 8, because that's the beginning one. And you want me to work out the sum of all the terms from the 50th term to the 100th term. So what I'm going to do is I'm going to do the 100th term first. So the 100th term would be, so everything up to 100 would be this, times 16 plus 99 times 7. So that would be 50 times whatever 99 plus times 7 is. That's 693 plus 16 equals 709. So it's 50 times 709, which equals, whoops daisy, 50 times 709 equals 35450. That's not the answer, because we've now got to get rid of, I think, the 49th term down, because the 50th term, yeah, let's say the 49th term down. So let's now try 49 over 2 times 16 plus 48 times 7. And that, I think, should give us, and then we take that away. There's a bit of me that's not entirely sure about this, because I'm trying to work out whether it's the 50th term or not that we do this with, but I think this will work. Equals plus 16 equals, and then times that by, let's just times it by 49 over 2. And that equals 6, 8. Well, that's at least pleasantly, so 8869, I think. I think it's 8869, 8869. And then let's just take away 35450 from that. And you get, so it turns out 50 to 100, sum of those would equal 26,581. Right, I think that did work, because if it hadn't, I don't think we'd get a complete number. The curve with the equation y equals gx is formed to the curve y equals minus gx by a single transformation. Describe fully the transformation that you would have to do. So for that, I think it's go through y equals 0. So it's flipping it. The diagram shows y equals fx. On the grid, draw the graph of 2 fx to the minus 1. So in this case, it's going to go, so x to the minus 1 means we go that way 1. Well, no, we go this way 1, this way 1, this way. Ooh, I'm not sure I can do that, somewhere around there. That way 1, etc. That way 1. So that's what we're doing basically. We're going that way. And then we've got to extend it by 2. So if it's 0, so if it's 3, it becomes 6. So if it's, so 2 times whatever's there becomes, this one is, hang on, that is 3, so that goes down to 6. That is minus 2, so that goes down to minus 4. That is 0, that is, yeah, that's it, that stays there. And then, so that's what happens. I think we arranged it so it goes like that. And then for this one, this would go one thing that way, and that would be 3, so that would go up to 6. So we're basically going like that. And then it will do the same thing on this side as well. That's not beautifully done, but you get the idea.